Hello everyone, how are you? How's everything? I hope everything is going well and you're getting ready for your first home take home assignment. So, I'm just recording this video to give you a very quick review just to tell you what to focus on and to make you sure that you don't need to worry about the assignment at all. Everything is gonna be fine. Just I'm showing you some of these slides that you might need to review again to make sure that you are prepared. First of all, of course, you're going to go over lecture 1 and 2, which are the introduction to the course. But then from lecture 3, make sure that you will understand the basic functions that we talked about the unit step function in discrete and in continuous time domain. And also we talked about the ramp function, and then we spent lots of time in class practicing how to draw these type of functions, especially when we face some shift in these functions, and especially when we combine the ramp and the unit step together. These are very important. I expect you to know them very well. And plus, you also need to know how to read a function. It's if something is given to you like this, so you should be able to read that function and write the f of t. So you should know how to, if a function is given to you, you should know how to draw it, and if a drawing is given to you, you should know how to read the function. This is very important, and I really invite you to go over all your class notes they had given you before all the closure of the university and these things. We covered all of this when we were in class, so I would like to invite you to go over it and make sure that you're comfortable with them, really comfortable with them. Also, I really want you to make sure that you understood the concept of even and odd functions, and either to see whether a function is even when it's symmetric with respect to the y-axis, or if it's odd when it's symmetric with respect to the origin. But most of the functions are neither even nor odd, you remember, right? In that case, we can actually write any function in terms of an even function and odd function. Also, make sure that you will refer to your notes in class notes and to the slides and these things to make sure that you understand and you're comfortable with this even and odd functions. The next thing that I want you to know and to practice a lot to be comfortable with is convolution. So you remember that what was the convolution, right? Convolution, we're using convolution to find the response of a system to an input where we don't know much about this system. We only know the impulse response of that system. So if h is the impulse response of that system, x is the new input. If we find the convolution of xn and hn, you will get yn, which is the response of this system to x of n. What was h of n? H of n was the impulse response. So we talked a lot about it, and I think you should be very comfortable with. Here in lecture note 5, it's also explained thoroughly, and it's explained in different way, using a graphical convolution or no. Use the method that you can do it on the paper. I recommend you to focus on the normal method of convolution, not on the graphical one, because I also told you some tricks, if you remember, in class, to make it as simple as possible. So it's not a very complicated topic, but it needs practice. So I also invite you to practice and make sure that you're very comfortable with convolution. In lecture 6, we talked about the continuous time convolution. So that you remember that we basically pass x of t over the h of t. So if you're choosing you're basically shifting the h of t all over the the domain, so from like minus infinity to plus infinity, but only at a very limited interval it's non-zero, and that interval is the interval that this h of t minus tau has some overlap with the x of tau. We also went over it and we saw that most of the time the response will look like this. Why? Because at this point actually the overlap starts and it starts entering into each other. At this point the overlap is complete and they are fully overlapped, and at this point one of them is moving out of the other one, so the overlap is being is reducing until it vanishes. So this one is also explained very well in lecture 6. You should be comfortable with this one as well. However, the discrete convolution is more important at this point. After that, I want to invite you to go over the Fourier series very well to understand the concept of the Fourier series, and also to go over the examples that we covered when we were talking about the Fourier series, with how we use the Euler expansion a lot. So remember, practice this with yourself to make sure that you know how to use the Euler expansion. Also make sure that you know the fundamental frequency and the fundamental period, very important, because the concept of the harmonies, what is the first harmonic, what is the second harmonic, third harmonic or something. And the important thing that you also need to know is the properties of the Fourier series analysis. In lecture note 8, we're going over the properties of the Fourier series, and these properties were we talked about the time shift, we talked about the derivative, which is very important. We talked about all kind of properties here. So when we talked about the conjugate, there is a table here that all the properties are explained, and this table is also found on lecture note 8. So this is also another topic that you need to be super comfortable with and practice. So as I said, these were the most important topics that you need to know, and I'm sure that you're going to have a very comfortable time in your assignment. If you had any questions, you still have time tomorrow. We have a class tomorrow, so come up with your questions and I will be happy to answer. So enjoy the rest of the day, have fun, take care, and I'll see you tomorrow.